Assalamualaikum and greetings to all evaluators. My name is Nur Shafika binti Miss D with the matriculation number of S56056 from Chemical Sciences Program. I am doing my final year project under Prof. Madiati SCHM Dr. Nohniza binti Harun. So my thesis title is the effect of different concentration of bridge 35 non-ionizing surfactant on emulsion polymerization of polyacrylamide nanoparticles. Polyacrylamide, a synthetic biodegradable polymer derived from acrylamide monomer, has piqued the interest of researchers, particularly in the industrial application due to its intelligent and unique characteristics as well as their properties. This project focused on the synthesis and characterization of polyacrylamide nanoparticles prepared via emulsion polymerization, as well as to investigate the effect of different concentration of bridge 35 surfactant on emulsion polymerization of polyacrylamide nanoparticles. The objectives of this study are to synthesize hydrophilic polyacrylamide nanoparticles via emulsion polymerization technique to determine the effect of different concentration of bridge 35 in the synthesis of polyacrylamide nanoparticles, and lastly to characterize polyacrylamide nanoparticles using FTIR, TGA, and SEM. Furthermore, although hydrophobic monomer and utilization of anionic surfactant in emulsion polymerization have the potential to be valuable in medical application and technology industry, further research is required to enhance the synthesis of hydrophilic monomer using non-ionic surfactant via emulsion polymerization. This research is also required due to lack of using non-ionic surfactant to synthesize polyacrylamide and insufficient of research regarding emulsion polymerization of polyacrylamide nanoparticles. The intention of this research is to synthesize polyacrylamide nanoparticles via emulsion polymerization technique, the fundamental characterization using FTIR and SEM, as well as studying polymer degradation characteristics using TGA will also truly discuss. Moreover, the effect of non-ionic surfactants concentration and the synthesis of polyacrylamide nanoparticles has been studied. It is used different concentration of bridge 35 which are below CMC, equivalent CMC, and above CMC. The chemicals used for the experimental procedure are acrylamide as hydrophilic monomer, bridge 35 as non-ionic surfactant, ammonium persulfate as initiator, and double distilled water as dispersion medium. Emulsion polymerization was conducted in a 3-neck bottom flask composed of nitrogen gas inlet, magnetic stirrer, thermometer, and a reflux condenser as shown in this figure. Initially, acrylamide monomer, bridge 35, and ammonium persulfate were dissolved in double distilled water. The experiment was held in the fume hood to protect from exposure to potentially chemical contaminants. To remove any soluble oxygen, the solution was purged with nitrogen gas for 15 minutes. The condenser's neck was sealed with a stopper that contained balloon to keep the reaction maintained in nitrogen gas condition. After 3 hours, the polyacrylamide gel product was cooled down at room temperature and the excess water was removed using rotatory evaporation. The synthesis was conducted for 3 times by using acrylamide monomer that was prepared at different bridge 35 concentration. FTIR analysis was used to determine the shifting in functional groups of the synthesis polymer PAM1, PAM2, and PAM3 compared to its monomer acrylamide. The main adsorption bands were alkane, carbonyl, CH2, and the most significant functional group predicted to be presented in the synthesis polymer is amide group. C-O adsorption band fell at 1638 cm-1, which satisfied the value that has been determined by Muhammad et al. 2013. On the other hand, CH was found at 2924 cm-1. The value of the wavelength obtained from the IR spectrum was agreeable with that reported by Singh and Mahto 2017 and also Singh et al. 2015. Moreover, CH2 had also been discovered at 1465 cm-1 in the polyacrylamide nanoparticles. Singh and Mahto 2017 was mentioned that the IR spectrum showed the band at 1456 cm-1, which is due to the CH2 scissoring. Most importantly, amide group of polyacrylamide nanoparticles can be found at 3326 cm-1. The result approaches finding by Chattat et al. 2017, where the adsorption band for amide stretch was 3448 cm-1. In addition, Chattat et al. 2017 have mentioned that the disappearance of the C band, which typically showed around 16,007 cm-1, demonstrated that the acrylamide monomer had been entirely transformed to polyacrylamide and that no monomer remained in the polymer. This is the wavelength of PAM1, PAM2, and PAM3 and its monomer acrylamide that have been found in the IR spectrum. Thermogravimetric analysis is generally used to evaluate the thermal stability of polymers. For this study, the acrylamide monomer and PAM2 nanoparticles were analyzed using argon gas flow with flow rate of 60 ml per minute and heating rate of 10 degrees Celsius per minute from 30 degrees Celsius to 600 degrees Celsius. PAM2 nanoparticles was chosen to be analyzed due to its stability during the polymerization process. Acrylamide monomer had shown 3 stages of thermal degradation where the onset temperature was at 40 degrees Celsius. At temperature approaching 216.67 degrees Celsius, second degradation was recorded while the third degradation stage was occurred at 432.50 degrees Celsius. Acrylamide monomer was completely degraded when the temperature reached 500 degrees Celsius until 600 degrees Celsius. On the other hand, synthesized PAM2 had shown 2 stages. The first onset temperature was observed at 30 degrees Celsius for the first degradation, while when the onset temperature hits at 333.33 degrees Celsius, second stage of degradation was occurred. PAM2 nanoparticles started to degrade completely after the temperature was elevated approximately 595.83 degrees Celsius. From the result obtained, it needs lower temperature to lose its mass compared to its monomer. These tables show the summaries, the wake loss and wake remaining of acrylamide monomer and PAM2 nanoparticles. Tabletop scanning electron microscopes (SEM) was utilized to observe the surface morphology of the synthesized polyacrylamide nanoparticles. 3 magnification values were used ranging from 250 until 3500. According to Ruschel and Bregel 1975, pure polyacrylamide hydrogels are thought to get a morphology bulb-like structure which connected by slender fibrils. PAM1 showed bulb-like structure that consists of multitudinous spherical units in random aggregation at lower magnification, while PAM2 had revealed the existence of the micro and nanopores as well as bulb-like structure were formed at 2000 magnification level. The morphology of PAM3 revealed parallel leaflet structure at higher magnification level. As a result, it is possible that different concentration of bridge 35 impact the shape of polyacrylamide nanoparticles. These promising results lead to the conclusion that different concentration of bridge 35 does give significant effects through the properties of polyacrylamide nanoparticles. Therefore, more research into this polymerization by using hydrophilic polymer should be conducted for the future sustainable. That's all from me. Thank you, stay safe and stay healthy.